Assalamualaikum to Dr. Sharifah. My name is Muhammad Afiq bin Mohtar from Group 10, and I will present about the group assignment for question number 2. The given question is, given a second order linear differential equation as follows: 4y double prime minus 37y prime minus 7y equal to cos hypotenuse 7x minus 2 exponential negative x over 4. For question A, identify the case for the complementary function of the given differential equation. For question A, we need to take the equation of 4y double prime minus 27y prime minus 7y and convert to equation of 4m power of 2 minus 27m minus 7 equal to 0. And by using the calculator and we use the simultaneous equation, we will get m1 equal to 7, m2 equal to negative 1 over 4. So m1 is not equal to m2, and this is case number 1. Next is question B. Convert function of x in terms of exponential functions. For question B, the only function of x in this equation is cos hypotenuse 7x. So by using the trigonometry identities, which is the cos hypotenuse x equal to exponential x plus exponential negative x divided by 2, and we use that trigonometry identities, we put in the equation, we will get the cos hypotenuse 7x equal to e exponential 7x plus exponential negative 7x divided by 2, and this is the final equation. For question C, solve the particular integral function yp using undetermined coefficient method. For this question, first we need to find yc by using the value of m1, which is 7, m2 equal to negative 1 over 4, and because of this is case number 1, we will get the equation for yc is a exponential m1x plus b exponential m2x. So the final equation for yc is a exponential 7x plus b exponential negative 1 over x. We just put in the value of m1 and m2 in the equation. Next, we need to find yp. We just put in the equation of exponential 7x plus exponential negative 7x divided by 2 minus 2 exponential negative 1 over 4x. Next, I separate the exponential 7x and exponential negative 7x to become this equation, which is 1 over 2 exponential 7x plus 1 over 2 exponential negative 7x minus 2 exponential negative 1 over 4x. And next, we need to compare with yc. We need to compare between yc and yp. When there is a same equation between yc and yp, the same equation in the yp we need to multiply by x. So in this case, the same one is c e 7x plus c exponential 7x plus e exponential negative 1 over 4x, same pattern with the yc. So these two we need to multiply by x, and the d exponential negative 7x is not same with yc. So the final equation for yp is cx exponential 7x plus ex exponential negative 1 over 4x plus d exponential negative 7x. Next, After we get the final equation for yp, we need to find the yp prime. So for the C, we can see that there is two variable, which is x and exponential, so we need to apply the product rule, which is uv prime plus vu prime. And the final equation for yp prime is c multiplied by 7x exponential 7x plus exponential 7x. And same with e, there is a product rule apply, so the final equation is e multiplied by 1 over 4 x exponential negative 1 over 4x plus exponential negative 1 over 4x and minus 7d exponential negative 7x. This is the final equation for yp prime. After we find yp prime, we need to find the yp double prime. For yp double prime, there is a product rule applied, and the final equation for yp double prime is c multiplied by 49x exponential 7x plus 14 exponential 7x plus e multiplied by 1 over 16 x exponential 1 over 4x minus 1 over 2 exponential negative 1 over 4x and plus 49d exponential negative 7x. After we find yp, yp prime and yp double prime, next we will substitute all the from the equation, which is 4y double prime minus 27y prime minus 7y. We need to substitute all the y with the yp prime and the yp double prime value from we get earlier, and this is the final equation that we get. So next step is we need to find the value for c and d and e. Any variables that we can find from this equation, we need to form it. For the first one, I take the variable of e exponential 7x and can get the answer of c from there. For c, I get the 1 over 58, and from variable of exponential negative 7x, I get the answer for d, which is 1 over 756, and for variable exponential negative 1 over 4x, I get the answer for e, which is 2 over 29. And this is the final equation for ypx. We just substitute all the variables, which is c, d, e, in the equation of yp. For question D, obtain the general solution. So the general solution, which is yx equal to yc plus yp. So we just combine the yc, which is a exponential 7x plus b exponential negative 1 over 4x plus the yp 1 over 58 x exponential 7x plus 2 over 29 x exponential 1 negative 1 over 4x plus 1 over 756 exponential negative 7x. And the last question is calculate the particular solution if the initial condition are given as y0 equal to 1513 divided by 756 and yx equal to 0. I'm sorry, actually this is for y and this is for y prime. So this is the answer for question E. For question E, for the condition of y0 equal to 1513 divided by 756, we just take the equation for yx from the question D, and we just put in the value of y, which is 1513 13 over 756 and x equal to 0. So we just put in the equation of yx, we can get the final equation, which is a plus b equal to 2. And for the condition of y prime 0 equal to 0, we need to differentiate the equation of yx from the earlier. First we need to differentiate, and then from the differentiation of the equation, we just apply the initial condition, which is y equal to 0 and x equal to 0, and from there we can get the final equation, which is 7a minus 1 over 4b equal to negative 1919 divided by 21,924. And by taking the first equation and the second equation, we can use the simultaneous equation to get the value for a and b, which is 0.0569 and b equal to 1.9431. Next, we get the particular solution for yx is we just put in the value of a and b in the yx equation, and this is the final equation that we get. That's all from me for the manual calculation. Next, this is the MATLAB calculation for question number 2. This is the coding for the MATLAB, and this is the output. As you can see right here, the equation from the MATLAB is same with the manual calculation. Same with here, this is the coding, and this is the final equation for the MATLAB, and it is also the same with the manual calculation we get earlier. And that's all from me. Thank you so much.